Today we are starting 10.4, which is inverses of trig functions. So you've actually used the inverse of trig functions before in geometry. In geometry, you use them with right triangles. We're actually going to do some of that tomorrow. But the inverses are used to find the measures of angles. And so you use the inverse whenever you are finding an angle measure. So if you look at your chart here, you have the sine of theta equals A, right? And then the sine inverse of A equals theta. They're just showing you that the input and the output switch. Do you guys remember back in semester 1, we were finding inverses of functions that looked like this, y equals x minus 4. And to find the inverse, do you guys remember what the first step was? Yeah, good. You switch your x and your y. So that's what's happening here is the theta and the a are being switched, okay? But sometimes you might see this as, sine of theta and then the sine inverse of theta, and that's okay. That's fine. Okay, sometimes, or they'll just put the sine of x, and then they'll say it's the sine inverse of x. Okay, so just know that that -1, that is read as sine inverse. Okay, so it's not an exponent or a power, it's just the sign notation. So, did you guys notice that this is called an inverse trigonometric relation here?
Yeah.
Okay, the reason why they call it a relation is because there's a very specific definition for a function. So if you think back to Algebra 1, do you guys remember what makes a relation a function? If there's one output. So for every input, there's exactly one output. Good. So you guys read through this. So for your inverses, the input can have more than one output. That's why it's not a function. Okay? Because you can have more than one output, which is what we're going to have for our first example. As we're going through today's notes, I'll also just give you some tips and tricks for helping you prepare for your quiz, which your quiz is next Wednesday, so 1 week from today. That is the 3rd of May. Okay? All right, so part of your quiz, you are going to have a unit circle. Part of it, you will not have a unit circle. And that's the part where you have to fill in the first quadrant. Okay, so we practiced that several times this week of filling in the first quadrant. Okay, so that's something that we should be able to do. So in example 1, we are finding all possible values. We're going to practice doing this. I'm going to let you use your unit circle for some of them, and then I'm also going to talk to you about strategies so you can do this without your unit circle, but only relying on the first quadrant, okay? So for the first one, you're going to find all possible values of the cosine inverse of root 3 over 2. All right, so in step 1, it says find the values between 0 and 2 pi radians. So when it says 0 and 2 pi radians, that just means one time around the unit circle. Okay, so you just have to find the values on the unit circle. That's what it's telling you. Radians are going to be how we're going to put our answer in that notation. So 0 and 2 pi radians. Everything's going to be in radians. So you have to find the values between 0 and 2 pi where the cosine is equal to root 3 over 2. Now remember, the cosine is where on the unit circle? Where do we look for the cosine values? Yeah, it's the x-coordinate. Great. So we're looking to see where the x-coordinate is root 3 over 2. Okay, now this is actually one that you should be able to do without your unit circle. At least the first value. Whenever I'm finding it without it, I always just draw a little visual. Do you guys remember which one of the points in quadrant 1, the x value is root 3 over 2? Yeah, 30 degrees, which is what in radians?
Pi over 6.
Yes. Okay, so at pi over 6, your point is root 3 over 2, 1/2, right? So because this is the x value, okay, pi over 6 is one place, okay? So again, that's a quadrant 1. That's something you'll be able to find. You'll have your quadrant 1 written down. Now, we have to find the other place. There is another place where it's root 3 over 2. So this is what we're going to use to help us. Remember yesterday we learned something about where all the functions are positive? Well, tell us how we know it.
All students take classes.
Yes, all students take classes. Good. So then, Adam, how do you know it's quadrant 4? You're right.
That's cosine of 4.
Yeah. Exactly. So you need the x to be positive. Cosine is positive in quadrant 4. So we just have to find the place in quadrant 4. Okay? It's going to be a reflection of pi over 6. So it's going to be this part here. Do you guys know what it is? 11 pi over 6 is right. One way you could think of it is this is negative pi over 6. So if you subtract from 2 pi, you get 11 pi over 6. Okay? So for that one, it's okay if you use your unit circle to look at that one. Do you guys know another way you could find what it is?
Look at your math circle.
You won't have it.
1 away from 12.
It's 1 away from 12. Yep, that's what I was saying. The subtraction. You could also just count, right? So if this is 1 pi over 6, isn't that how we labeled the unit circle, is by counting? So you could just go 1 pi over 6, 2 pi over 6, 3 pi over 6, 4, 5, 6, 7, 8, 9, 10, 11. Okay? Okay, and then this is going to lead us to step 2. Okay? So for step 2, we are going to find the angles that are coterminal. So think about what that means. Coterminal with angles measuring pi over 6 and 11 pi over 6. Okay, so I want you to take a minute and I just want you to think about, on our last quiz, we found angles that were coterminal. What did we do? Okay, and then I just want you to tell the person next to you what we did. Alright, did you guys come up with it? What do we do?
We added 360 or subtracted.
Yeah, you add 360 or subtract 360. So remember, coterminal means that you have the same terminal side. So you don't have to write this down. Visuals help, okay? So, look away. All right. So what we did in 10.1 is we graphed the angle. You had to find the coterminal angle, which meant it had the same terminal side, right? So you have this angle here, but couldn't you just go 360 and end up at the same place? And couldn't you do that an infinite amount of times? You could keep going 360. Okay? 360 is equivalent to how many radians? 2 pi. Great. Now, yes, so we could add 360 or we could subtract it. So if we subtract it, all we would do is go in the opposite direction, right? So when we are trying to find all of the possible values, that means we're using coterminal angles. And how many coterminal angles are there with pi over 6 and 11 pi over 6? An infinite amount. So we have to write this a special way, okay? So your final answer is going to be written as pi over 6 plus 2 pi n, and this is where n is an integer. Okay? Okay, so pi over 6 plus 2 pi n, where n is an integer, and then 11 pi over 6 plus 2 pi n. And again, n is going to be an integer. So I'm going to let you write that down, and then I'm going to explain that part. Okay?
Is that going to be what it looks like for every single answer?
Yes, so for every single one where you are finding the possible values, you will always add 2 pi n. So the 2 pi represents what? The 360 degrees, so one time around the circle. So 2 pi is one full time around the circle. The n represents an integer. So if I were to plug in 1, how many times around the circle am I going? 1. If n was 5, that just means I would go around the circle 5 times. Integers also include negative numbers. So if n was a negative value, then I could go in the opposite direction. So the reason why you're adding the n is because there's an infinite amount of values, and the 2 pi comes from the 1 rotation. So you're always going to be adding your 2 pi n when they ask you for all possible values. Okay, can you guys think of questions you have for me about this? All right, so then let's try B. So for part B, we have the tangent inverse of negative root 3. The tangent inverse of negative root 3. Okay, so while we're taking these notes, you're going to notice I'm writing down things that you should be thinking about when you do your homework. Okay, these are really going to help you with your understanding. It's not something you have to write down with all of your homework problems, but it is something that you should be thinking about. So for this one, the tangent inverse, we'll try to lock that in. Yes. And I just pushed it, and that's what it happened. So we're going to find where the tangent is equal to negative root 3. So this means find where the tangent is equal to negative root 3. Okay, so before we do that, I want you to think back to yesterday about the little chart that we drew. Okay, and if you need to, you can glance at it on your unit circle.
That's 60. Is it 60?
What's that?
Is it 60?
Yes, but we're going to use the radian value, which is? Yes. Okay, so yesterday we drew out a little handy-dandy chart, okay, and we labeled where the tangent values were in the first quadrant, okay? So this is something that you should have memorized. Like I said, doing your homework is going to help you with that. So the first one is root 3 over 3. What's the second one? 1. And then you guys are thinking of the points. This is the tangent, right? So this is in the bottom of your unit circle paper. Okay, so for the tangent, these go in order of least to greatest, right? Root 3 over 3 is the smallest, then 1, then root 3. Okay, so pi over 6, pi over 4, pi over 3. Okay, so then let's just write this on our unit circle model. Okay, so here at pi over 3, I know that the tangent is root 3. Okay, that's great, but I'm trying to find where the tangent is negative root 3. So again, I'm just going to use the all students take classes. But remember, all students take classes is where it tells you where the functions are what? Positive. So if I want to find where the tangent is negative, that's where? So circle. Okay, so tangent will be positive here and positive here. So that means it's not positive here and it's not positive here. letting that sink in for a second. So if you have your all, put that away. 8, so if you have all of your positive values in 1 and 3, that means your negative values are in 2 and 4. So if I have to find what they are, remember, you can just count using how we set up the unit circle, okay? So if you have 1 pi over 3, that's 60 degrees. I'm just going to go here to 2 pi over 3. Where's 3 pi over 3? Here. And then I have 4 pi over 3, 5 pi over 3, and 6 pi over 3 is at the 2 pi. So your final answers are going to be the ones in quadrant 2 and in quadrant 4, because that's where they're negative. So that's how you can use the first quadrant to help you find which ones are negative. Okay? Okay. Ask me some questions as we're processing. So, do we understand why we're using quadrant 2 and quadrant 4? Do we need to review that? Do you understand it? Okay. All right. And then, do you guys understand how I found the radian values? Give me that. Just give me a nod or a... Yeah. Mm-hmm.
I remember you did something yesterday where it's like you only really have to remember the first part.
Right.
It's 21 points. If you take like say like the 2 out, you can see that it's like basically anything up to like 60, I think that's or
Yes.
pi over 3.
Yep, exactly. Pi over 3. And to find what pi over 3s they are, I was just showing you how you could count the same way we set up the unit circle. So this would be at 1 pi over 3, that's 60 degrees. You can go 60 more degrees to get the 2 pi over 3, and then 3 pi over 3, 4 pi over 3, 5 pi over 3. So I'm going 60 degrees every single time. And then because I know tangent is negative in quadrant 2 and negative in quadrant 4, I'm going to select those two. So then my final answer is going to be 2 pi over 3, and what do I have to put with it?
Plus 2 pi.
Yes. And then 5 pi over 3 plus 2 pi. Okay, so these two are your final values. All right, now the next thing that we're going to talk about today are restricted domains. And in this textbook, and in this textbook only, they represent the trig functions that have a restricted domain with a capital letter. Okay? When you go to next year or anywhere else, they will not have a capital letter. They'll just be restricted. Okay? When we're first learning this, it's actually helpful so you can see the difference between them. But the reason why there are restrictions goes back to what we wrote down earlier. Remember how we talked about inverse functions are not functions because they have more than one output? If we use these restrictions, it means that they do only have one output. Okay? We'll go more into why these make it one-to-one when we start graphing these. But for today, all we need to understand is that these make our function, so you only have one output now instead of two. So the way that you are going to see this written is in set builder notation. So when you see the capital sign, it's the sign of theta for all the values of theta, such that negative pi over 2 is less than or equal to theta, which is less than or equal to pi over 2. So what that means is all of the values are in between negative pi over 2 and pi over 2. So what we're going to do is we're going to represent this visually. So we're going to draw a circle. And can you guys label where pi over 2 and negative pi over 2 are? Where's pi over 2? Yep, at 90 degrees. Where's negative pi over 2? 270, yeah. Okay, so if this goes from negative pi over 2, if it starts here and goes up, it's going to cover all of quadrant 1 and all of quadrant what? 4. So when it's saying that this is the restriction, what it means is you are restricted to quadrant 1 and quadrant 4.
Why is it 1 and 4 and not 2?
Because it's from negative pi over 2 to pi over 2. So you have to go from negative pi over 2 to pi over 2. Oh, yeah, so you start here, right? So you start at negative pi over 2, and then you go up. No, that would be from pi over 2 to that, and that wouldn't make sense. Yeah, you have to start where it tells you. So you start at negative pi over 2, right? And then it goes there. So it's in between those two. Okay, and then your cosine is the cosine of theta for, and then theta such that theta is between 0 and pi. Okay, so cosine of theta for the values of theta such that theta is between 0 and pi. Sorry for the giant less than or equal to sign. We feel like I need to even them out now. There we go. Okay, so let's draw a picture of this. It's because I started to make the pi, but I didn't put that in there. Alright, so then let's draw this. So if I start at 0 and go to pi, I have to start at 0 and then go to pi. What quadrants is that going to be? Good. Quadrant 1 and quadrant 2. Okay, and again, remember, this definition is coming from a place where it's going to make it one output. All right, now the last one, the tangent, is actually very similar to the sine. There's just one small difference. I want to see if you can find it. So this is the tangent of theta for the values of theta such that theta is between negative pi over 2 and pi over 2. Okay, so what is the only difference? Yeah, it's not equal to, okay? So I want you to think back to some of the things we talked about yesterday with tangent and think about why that is. Now, it goes from negative pi over 2 to pi over 2, so that means the restrictions are going to be where? In what quadrants? Yep, same as sine, so quadrant 4 and quadrant 1. Quadrant 1 and 4. Okay, so negative pi over 2 to pi over 2. Okay, now, can anybody tell me why this is not going to include negative pi over 2 and pi over 2? Yeah. Yes. Do you guys remember at pi over 2, what is the value of tangent? We wrote this down yesterday, right? No, it's undefined. Why is it undefined? What is this point? Yes, so this point is 0, 1. You can't divide by 0. Okay, so that's why it can't include those. All right. And then on the back, we're going to look at this special chart for the inverse of trig functions. Okay, if you have some highlighters, you might want those for your chart. Okay, so the first function we're going to look at is the inverse sine. Okay, so the inverse sine, like I told you in this textbook, it is related with a capital letter. So you can call this the inverse sine function. It also has another name. It is called the arc sine. The arc sine. Yeah, and then the cosine, the inverse cosine function, you can call that the arc cosine. And then, of course, for tangent, the inverse is arctangent. Now remember, this is different. The inverses are different than the reciprocals. So sometimes people get those confused, okay? The inverse of sine is going to be the sine inverse of a value. So it could be A. What is the reciprocal? What's the reciprocal of sine? What's that called? What's the reciprocal? What is it? Yeah? And that would look like this. Okay, so the inverse is the sine inverse. This is going to be the cosecant. You can go straight to the testing center. You can go to the straight to the testing center to do your quiz. What? Mm-hmm. Yeah. That at Four Corners, like you're going to the lunchroom. Right on the
On the side.
Yeah. It's room 306. It'll say your testing center. 306. Okay, and then I just want to get those straight because we have to know the difference. So there's inverses and there's reciprocals. Okay? Now, look at the domains here. The domain for tangent is negative infinity to infinity. What that means is there is no restrictions. That is not the case for the sine and the cosine. Okay, the sine and the cosine both have restrictions. The values that you plug in have to be between -1 and 1. And when you plug in those values, the range, which is the output, okay, the output is going to be exactly what we just talked about. So for the sine function, this is telling you that your range, this is going to have to be somewhere in quadrant 1, okay, or quadrant 4. This one is quadrant 1 or quadrant 2. This one is quadrant 1 or quadrant 4. Okay, so the directions for these are a little bit different. They are not going to ask you for all the possible values. Okay, so that means you don't have the plus 2 pi n. What you're going to do is evaluate each inverse trig function, and then you're going to give your answer in both radians and degrees. Okay, so again, this is something that we'll have to know how to do without a unit circle and with it. I'm not concerned about you finding it with it. I think you're going to be really good at that. So we're going to practice doing some of them without. So the first one, this is the cosine with a capital C inverse of -√3/2. Okay, the step one is just going to be us thinking about what are we looking for. So when we have this capital C, what we're thinking about is where in, and then for cosine, it's quadrant 1 and quadrant 2. So where in Q1 or Q2 is the, and remember cosine is the x-coordinate. Okay, so where is the x-coordinate? Negative root 3 over 2. So like I said, if you had your unit circle, that would be super simple, right? You would just look at your points and you'd see, okay, which one in quadrant 1 or quadrant 2 does my x value have negative root 3 over 2? Okay? Do you guys have any questions about finding it with your unit circle? With it? Because you're going to have to know both. So part of it you'll have with it, part of it you'll have without. You could always draw it though. You could always draw it out and find it. But you're going to have to know how to do it with both. Okay? Alright, so when you have the cosine, okay, you're going to have your unit circle. And then what we're going to do is we're just going to ask ourselves, where is your cosine positive root 3 over 2? Okay, so it's always going to be, like, I always think of it in terms of which one of these three, right? Okay, so if it's at 30 degrees or pi over 6, your cosine is root 3 over 2, 1/2. Okay, how can we find where it is in quadrant 2? Yeah, Tony, what are you thinking? What? Caleb? That I would count it, yeah. So if this is 1, 2, 3 here, this is 1, 2, 3 here. Yeah, they're always reflections, right? So if this is pi over 6, this is where we need to go. And there's lots of different ways you can do that. Yeah, you can think of this as pi over 6 or 30 degrees. You can also count. If this is 1 pi over 6, this is 2 pi over 6. This is 3 pi over 6, 4 pi over 6, and this one is 5 pi over 6. Okay, you can also, I like what Caleb said, if you know this is 30 degrees, right? What's 180 minus 30? It would be 150, and then you could convert to radians. That would be fine, but this is going to be 5 pi over 6. Yep, that's your final answer. 5 pi over 6 and 150 degrees. So you have to have it in both radians and degrees. Alright, and then the sine inverse of 3 over 2 is the next one. So what we're going to ask ourselves is where in Q1 or Q4 is the y-coordinate 3 over 2. So for sine, your restrictions are Q1 and Q4. Okay, now if you're thinking about what the values of y are in the unit circle, there's only a few numbers that your y-coordinate can be. Okay, it can be 1/2, can be root 2 over 2, could be root 3 over 2, could be 1, could be 0, could be -1. Is that any of those values? No. Root 3 over 2 is on there, but 3 over 2 is not. So what this means is this is not a special point on the unit circle. Just because it is not a special point, that doesn't always mean that it's not on the unit circle. Okay, because I told you earlier that you could have radian values that weren't with pi. Okay, but this is not a special point on the unit circle. So what we're going to do is I'm going to show you how to use your calculator, okay, to find values that are not special points on the unit circle, okay? So what we're going to do is we're going to make sure our mode is in degree. Okay, so have your calculators out. Yep, and we're going to do that too. Okay, so we're going to make sure that our mode is in degree mode. Okay, and then what we're going to do is we're going to find the sine inverse. Now there's no capital sine inverse, you just have the sine inverse. So after you have it in degree mode, I want you guys to do the sine inverse of root 3 over 2.
Is it 3 over 2 or just?
Hold on 1 second. Okay, so when you do the sine inverse, it's right above the sine, okay? So second sine inverse of 3 divided by 2. What happened? Okay, so remember up here, if A is not between -1 and 1, doesn't fit in the domain. So what do you think our answer is going to be? No, but you're close. Yes. So since 3 over 2 is greater than 1, okay, it is not in the domain. So you may realize that right away, okay? You may realize that's not in the domain without even plugging it in. That's great. Okay, so what you would write is that the sine inverse of 3 over 2 equals undefined. So that would be your final answer, is that it's undefined. Okay, so let's go back and let's check our first one. Okay, so let's check and make sure this is it. So I'm just going to do the sine inverse of negative root 3 over 2. Make sure you use your negative and not the minus. We'll do the square root of 3. Make sure that you cut that out. Oh yeah, I'm sorry. Yes, thank you. Cosine. And then, what should I get? Yes, because I'm in what mode? I'm in degree mode. You guys want to see what happens if we're in radian mode? Good, we will. Okay, and remember, degree and radians, they both measure the same thing. What do they measure? What do they measure? That's the unit. Does Fahrenheit measure Fahrenheit?
Yeah.
No.
Temperature.
Yes, it does.
Okay, Fahrenheit measures temperature. What do degrees and radians measure? Angles. Okay, so if I put this in radian mode and do the same thing, what do you think I'm going to get?
5 or 6.
Okay, let's see.
Yeah, I don't like it.
Okay, what do we think this is?
5 or 6.
As a decimal.
Oh my gosh.
Okay, so it gives you the radians, but in decimal form. Okay?
Wait, that's not
I know, you do have to write it like this.
in the domain.
Yeah, it is. Negative root 3 over 2. Negative root 3 over 2 is in between negative 1 and 1. You look at the decimal. Oops, that's 32, which obviously is not. That's 2. But negative root 3 over 2 is a decimal, okay? That's in between. So negative root 3 divided by 2.
Oh, I thought that answer.
Okay? No, your answer's in the range. Okay, so then the last one we're going to do this without your unit circle, is the tangent inverse of root 3 over 3. So we've already looked at our tangent value several times today. So if it's the inverse, you ask yourself where in Q1 or Q4 is the tangent root 3 over 3. So will you guys find that for me?
What? This is
So first, where is tangent positive, in Q1 or Q4? Q1. Everything's positive in quadrant 1. So where is the tangent root 3 over 3? Yeah, pi over 6 right here. Okay, at pi over 6. So your answer is going to be pi over 6, which is what in degrees? 30. Right? So if it's root 3 over 3, this is at pi over 6, and we know pi over 6 is 30 degrees. Okay? Alright, so I'm going to give you the rest of the time to work on your homework. Okay? And I know I keep saying this, but in order to get familiar with the unit circle, to be ready for your quiz, you need to make sure you're practicing your homework. Okay? If you don't, you're going to run out of time on your quiz and you're not going to be able to finish the whole thing. Okay? So it's really, really important that we get this practice in.